In this video, we will discuss the problem minimum exchange. The problem says that we'll be given a matrix which will be of size n cross m, and every cell of the matrix contains either the character A or it contains the character B. Okay, so every cell in the matrix will be having either the alphabet A or alphabet B. Now, exchange in this problem is defined as swapping characters between two cells. So exchange is nothing but swapping operations. So in this case, you can say that you have to find the minimum number of exchange means minimum number of swaps. So your task is to find the minimum number of exchange that is required to rearrange the given matrix such that no adjacent cells have the same character. So two cells are adjacent if they share one of their common sides. So if in the left side, right side, front side or back side, they are same. So let's quickly take an example of a matrix to understand what does it mean by adjacent. So suppose that we have a matrix and we have an alphabet A here. So for this alphabet A, the adjacent cells will be considered in the left side, right side, upward and downward. So these four cells will be adjacent. So if there is a A here, or if there is a A here, or if there is a A in this direction, or if there is a A in the downward cell. So if any of the cells has A, so that will be considered, in this case, it will be considered that the adjacent cell is the same. So basically what they want is, they want the adjacent cells to have different character. Okay, because for if there is a A here, then adjacent cells will be different than that. Okay, that is what the question is expecting. And you have to find such a configuration in which you will do the minimum number of swaps. Okay, now let's quickly discuss the sample example as well. So suppose you have been given the sample example like this. So let's quickly copy this first of all. So suppose we have been given the sample example as A, then we have been given a, then B, then we have been given A, then B, then A, then B, and then A. After that we have been given B, B, A, B. So in this case, if you will observe, so basically this A you can observe is the, like in this case this A is adjacent, right? And you can also observe that maybe this particular B that we have, it is also the same, right? So you have to find the minimum number of swaps. So there are two kind of configurations that you can have, because if I will tell you something, let's say this example is given, but let's take a much more smaller example than this. Okay, let's say that we have been given a 1D array only. Think of a 1D array. So if I ask you that I'll give you a 1D array and you have the characters A and B, and you have to put them in such a way such that no two adjacent characters are the same. So you will tell me that what you can do is you can put it like AB, 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 this kind of thing you can do, right? Or you can tell me that another pattern that you can have is BA, BA, BA. Like in the 1D array, you can tell me this thing, correct? So basically you can say that at the, like let's say this is 0, 1, 2, 3, 4, 0 based indexing. So maybe you can say that at the even, like at the even indexes you will have A's, or at the like at the even indexes you will have B, and vice versa, right? So you can tell this thing that okay, at the, if either I can follow the pattern strategy of this or this, and based on this, if the characters are not the same, then I can count them, and in the end like whichever pattern gives me the smallest possible answer, like minimum swaps, so that I can take, correct? Now talking about this particular problem as well, so in this case we can observe that we can have two kinds of pattern. Either we can have A, B, let's say A, B, right? First of all, then we can have what? Then we can have B, A, B, A, and then A, B, A, B, A, B. This kind of pattern we can have, right? Another pattern that we can have is this one. That is nothing but B, A, B, A, right? Start. That means the second pattern starts from B. Now after that, I'll have A, then B, then A, B, then B, A, B, A. Okay, now if you will observe, so see there are two kind of choices of the patterns that we can have. Either we can have this first kind of pattern, or we can have the second kind of pattern. So for the given matrix, for this given green matrix, either we can choose to make it like the first kind of pattern, or we can choose to make it like the second kind of pattern. So which pattern will we like to have? That is the concern. So if we will see here, so in this case we can clearly observe that if we will see, so here A is the same. So this A is same. Then second A and B is not the same. So we'll mark our count as 1. Then we can see B and A. So we are again not getting. So we'll mark the count as 2. Then this A and this B is not the same. So we'll mark the count as 3. After that we move to the next row. So this B and this B is same. This A and this A is same. This B and this B is same. This A and this A is same. After that we move to the next row. So B and A are not the same. So we'll update the count to 4. After that, this B and this B is same. This A and this A is same. This B and this B is same. So now we can say that count is 4n. So for doing this kind of swapping, basically we'll require count is equal to 4, or you can say mostly 2 swaps. Okay. Now, if you will observe in the second part, like if you will observe in this particular part, so what is the scenario here? So let's mark our count here as 0 initially. Okay. Now if you will see, this is a here, like, and this is a B here, so we'll update the count to 1. After that, if we see again, so this is a here, this is a here, so characters are same. Then we move forward. So this is a B here, this is a B here, this is a, this is a, so no change. B A, okay, so B A, so I will update it to 3 because they are not the same. Then B A, so A B is written, so again I'll update, like two characters are not the same again, so I'll update it to 5. Then B B, so this is a B, this but correspondingly there is a, so again it will get updated to 6. Okay. After this, if we see, so there is a and there is a B, so again two, like A and B is not the same and B and A is not the same, so I'll update it to 8. Now if you will see, here the count is 4, here the count is coming out to be 8. Let's check the answer for this. So if you will check the answer for this particular case, so you can clearly observe that count is coming out to be 4, correct? So in this case, which counter will you return? You will return the minimum out of the two, right? So you'll return this in which the count is coming out to be 4, because if you compare this and this, then only 4 positions are different. So you'll return this particular count, because if you follow the second pattern, in that case the counter is coming out to be 8, so you need to change 8 positions. That's quite a lot of cost. So in this case the minimum cost is 4, so that is what you are returning in this case, right? How do we get an idea to generate this kind of a pattern? Okay, that is the concern here. So in this case, what we can say here is that if you try and observe, so we need to have this kind of a pattern, but how can we observe it? So see, if we are, suppose that we were given a 1D array, right? So as I said, if we are given a 1D array kind of thing, then you can have A B A B A, right? This kind of a pattern, right? Basically indirectly you can have this kind of a pattern, or you can have B A, like let's quickly write this here only. Okay, so let's say this is the index 0 1 2 3 4 and 5. Okay, now in this case if you will observe, so what are we having? So at the even indexes, either I can say that what can happen is, at the even indexes I can have A's. Okay, in the first choice, at the even indexes I can have A's, and at the odd indexes I can have B's. Okay, that is one thing that I can say, that at the even indexes, let's say I have A's, and at the odd indexes I have B's. This kind of a pattern. Now, if I want to follow this kind of a pattern, so basically whatever string, whatever 1D array, suppose if I'm talking about 1D array, so whatever 1D array will be given to me, right? So in that case I can compare it, that if at the even position A is there, then no problem, I'll not count it. If at the odd position there is a B, so no problem, I'll not count it. But if at an even position there is a B, then I'll update my counter by 1. If at an odd position there is a, then also I'll update my counter. Okay, so whenever the expected character is not there, then at the even or the odd position, then I'll update the frequency, right? Then I'll update my counter. Similarly, what I can say is, let's say I have a matrix, let's say I have an array, like let's say 0 1 2 3 4 5, let's say this kind of indexing. Another kind of pattern that I could have followed is BA. This is, I'm talking about 1D, then we'll also shift to 2D, for that is for this particular problem. Okay, now if you will see here, so what will happen, in this case I can say that at the even indexes, what do I want? I want a B, and at the odd indexes I want a, correct? So what I will do is, I'll traverse through the original string that will be given to me, original array that will be given to me. And what I will do is, if at the even indexes there is a B, then I'll not update my counter, because if at the even position there is a B, then there is no problem. If at the odd position there is a in this particular pattern, so there is no problem. But if at the even position in this pattern, if at the even position there will be a, then I'll have to update my count. And if at the odd position there will be a B, then also I'll have to update my count, because if the desired characters are not there at the even and the odd position, in that case I'll update my counter. And let's say from this pattern I'll get a counter 1, let's say from this pattern I'll get a counter 2, so whichever counter is minimum, that I can return. Now the question is, like, how do we do this same thing for the sample case, that is for the 2D matrix? Okay, so in 2D matrix, how do we check for this thing? So in this case, what you can observe is, you can, like, this is one observation that you can always keep in mind for various types of problems on matrix if you want to follow this pattern thing. So what you can say is, let's say I do the indexing of the matrix. So this is 0, this is 1, this is 2, this is 0, this is 1, this is 2. So indirectly you can say that this is nothing but 0 comma 0 row. You can say that this is 0 1. Okay, you can say that this is 0 2. This is nothing but 1 comma 0. This is nothing but 1 comma 1. This is nothing but what it is nothing but 1 comma 2. This is nothing but 2 comma 0. This is nothing but 2 comma 1. This cell is nothing but 2 comma 2. Now you'll say that how does that help? So this is the unique selling point of a 2D matrix, because if I will now add these values up, right, I am basically now I'm telling that I am adding these indexes up, right? So I'm telling you in terms of index only. Don't worry, the alphabets will be there here, but I am currently putting, like, I am telling you about the indexes. So let's see. So in this case, if you will try and observe, so what is 0 plus 0? 0 plus 0 is nothing but 0 only. What is 0 plus 1? That is nothing but these values represent nothing but the pair of I and j only, na? They are representing I and j only. So basically I'm doing I plus j only, right? I am doing I plus j, and then I'm telling you about the indexing thing in the matrix, like how you can observe. So if you will see, this is 0. Now 0 plus 1 will be 1. Then 0 plus 2 will be 2. Then 1 plus 0 will be only 1. Then if you will observe, so 1 plus 1 will be 2. Then you will observe that 1 plus 2 will be 3. Then you will observe that 2 plus 0 will be 2. 2 plus 1 will be 3. 2 plus 2 will be 4. Now how does that help? So if now you will observe in this particular matrix, so what are the opportunities that you have? Because this is nothing but I plus j addition, right? This is nothing but indexing of matrix based on I plus j. So if you will observe now, so what happens? If you will see, so the first, can I say that the first column, that is 0, like this particular thing is nothing but 0. So that comes in the even category. So let's say I write a E here. Okay, let's say that I represent it by E. Now again there's a 1. So after that, if there's a 1, so I can represent it by odd index, right? Now if there is a 2, so I can say that this is even. Now if I see this is 1, so that is nothing but odd. If I see 2, so that is even. If I see 3, that is odd. If I see this thing, that is 2, so that is even. Now if I see this 3, so that is nothing but odd. If I see 4, that is nothing but even. So you can see that alternate patterns are followed, right? You can see that based on I plus j, based on I plus j, because in the 2D matrix, how do I do the indexing? In a 1D matrix, in a 1D array, it's very easy for me to tell 0 1 2 3, that even and odd indexes, right? But in the 2D matrix, how do I do the indexing thing? So for that, you can use I plus j always. This holds true for all the cases, right? Whenever you want to use this pattern, you can use. So I plus j, alternatively, it shifts to even and odd kind of situation. So basically what I can try to do is, one time I can try to build the pattern A B A, right? Then B A B, right? Like if I'll tell you A B A B A B, then what? A B A, right? This kind of thing. This is the first kind of choice that I can have. Or the second kind of choice that I can have here is, this is the first kind of choice that I can have. The second kind of choice that I could have had here is nothing but starting from B. That is this particular pattern. So let's quickly copy this so that we are more clear with this thing. I'll copy these two things. Then we'll see further. So now what I can say here is, let's say this is the scenario here. So let's quickly check. So now, if suppose that this is the I and j scenario, right? This is nothing but I plus j kind of built matrix, right? The indexing, the numbers shows I plus j. Okay. Now, what we can do here is, you can see that even and odd and even and odd, odd even. So there is a alternate pattern, right? Alternate pattern is being followed. So what are the choices that I can have? Either I can have a B, A, right? I can have A, B, like B, A, B. Then I can have what? A, B, A. This kind of pattern. This is the choice one that I can have. Now in the choice one that you can see, so in the choice one, what happens here? You can see at the even index there is a. Okay. So in this pattern, I'm trying to say that at even I'm expecting a, and at odd I'm expecting a b. At odd indexes, that is dependent on I plus 1, I plus j value. I plus j can be even or I plus j can be odd, and it follows the alternate thing as I've discussed. So if I can say here that if I plus j is even, then I'll put a here. If I plus j is odd, then I'll put a b here. Okay. But if at the even position, if I plus j is even and I have a b there, suppose in the matrix that is given, if there's a if at the even position, that is I plus j is even, then I have a b here. Suppose that I'm trying to follow the first kind of choice, that is this pattern, that is a b a, b a b, and stuff like that. So in that case, if at the expected even index, if there is a b character, so in that case what I'll do, if at the even index, they like that is nothing but I plus j, if there is a b character, in that case I'll increment the count. And if at the odd position there is a character A, then also I increment my count, right? That is nothing but count 1 plus plus, you can say, right? So that is when I will be incrementing the count. Now, what is the second kind of pattern that I can have? The second kind of pattern is nothing but BA, B, then ABA, and then BAB. Now, if I talk about this particular pattern, so what can I do? If I talk about this pattern, so if like I can say that what? At the even indexes in this pattern, I am having at the even indexes, I am having nothing but B. And at the odd indexes, that is nothing but I plus j value considering odd or even. So at the odd indexes, I am having A. So if it happens that if at the even indexes, I encounter A in this case, in this kind of a pattern, if at the even indexes, I'll encounter A. So I'll do choice 2, like counter 2 plus plus, right? Counter 2 indicates that I need to change this particular thing, right? In this choice 2. And if at the odd indexes, I'm expecting a, but I get a B. So I will do what? I'll do a counter plus plus. And in the end, as we have already discussed by seeing the very first basic test case, initially as I have told you in a dry run, whichever counter is minimum, right? Minimum of counter 1, comma counter 2, that is what I can return. So now let's quickly write the code for this approach and see what I can do. So what I'll be doing here is I'll be given the matrix. So let's quickly get the size of the matrix. So let's say int n is equal to nothing but the matrix of size, matrix dot size. Okay. Now let's see the dimensions of this matrix as well. So it says that it is a n cross m matrix. Okay. So n is equal to matrix dot size, and let's say m is equal to nothing but matrix of 0 dot size. After this, what I'll do is like I'll have a count 1, that is for the first kind of choice if I want to have. So I'll initialize the count 1 as 0. Then I'll iterate through the matrix. So I starts from 0, I is lesser than n, then I plus plus. And then what I will do is I'll say that okay, j starts from 0, j is lesser than m, and then I'll do a j plus plus. And after this, what will I do? So I'll say that if I plus j, okay, suppose that I'm trying to follow the first kind of pattern. So that is, this is nothing but the choice one, let's say, right? This is the choice one or the first kind of pattern, let's say. So in this case, at the even indexes, whenever I plus j value is even, then I want a, okay? So this is pattern when I'm trying this thing, that is a, b, a, right? Then I'm wanting what? B, a, B. That is nothing but at the even in the, like at the even positions, I'm wanting a, and at the odd positions, I'm wanting a B. So if I iterate through the original matrix, the matrix that has been given to me, and if at the even position there's no A and there's B, so in that case I have to increment the count. And if at the odd positions, if there is no A, like if at the odd position, if there is a B instead of A, in that case also I have to like increment the count, because if at the even position there is a, then I do not have any problem. But if at the even position there is a B, then I'll increment my count. And similarly, if at the odd position I have a B, so I do not have any problem. But if at the odd position I have a, then I'll increment the count. Okay, so that is what I'll be doing here. So if I mod j, like I plus j mod 2 is equal to 0, right? So if this is what, this is when the position is even. So if the position is even, if there is a, then I'll not increment my count. But if at the even position in the first choice, if at the even position, if there is a B, then I'll increment the count. So I'll say that if it's an even position, and if at the even position, if the element at the even position, if the current at the even current even position, if it is a B, then I'll say that okay, let's increment the count 1 plus plus, right? That is what I'll be doing. Otherwise, if the current position is odd, so if the current position in the choice 1 format, if the current position is odd, so if it is odd and it is B, then I do not have any problem. But if it is odd and it has A, then I have to change it. So in that case, what I'll say here is, I'll say that if at the odd position, right? This is when I'm talking about the odd position. So if at the odd position, uh, if I have a B, then I do not have any problem. But if at the odd position, if I have A, then in that case I need to count it, because I'll change it. So I'll do what? I'll do count plus plus. Okay. So let's do a count plus plus. So this is what I'm doing for the first type of choice. That is nothing but this particular pattern. That is ABA, BAB. Okay. Now let's run the same loop. Like you can do it in the same loop also, but for clarity purpose, I'm running another loop. But you can do it in the same loop if you want. Now, since I want more clarity for you, so I'm doing it in this another loop. But you can do the same counting in the this loop only. But just to not have any confusions, let's do it in another loop. So B, A, B, the second pattern will be nothing but the second kind of choice pattern that I can have is nothing but B, A, B, then A, then B, and then A, right? Basically this pattern, like B, A, B, A, B, A, and this stuff. Now in this pattern, if I'll observe, so at the even indexes, I am having a B, and at the odd indexes, I am having a A. Okay, so let's quickly write the loop also so that we can understand better. So what I am saying here is that we can run a for loop, like for I starts from 0, I is lesser than n, and then I'll do a I plus plus. Then what I'll do is I'll say that okay, for int j starts from 0, j is going to be lesser than m, and then I'm going to do a j plus plus. After this part, what I will be doing here is if the I plus j modulo 2 if is equal to 0. So if the position is even, so if the position is even, then I want a B. So if the position is even and the character is all, like if the position is even and the character is B, then I do not have any problem. But if the position is even, if the position is even and the character is A, then I'll increment the count because I need to change it. Because at the even position, I'm expecting a B, not a A. So if at the even position, if I have A, so in that case, I'll increment my count. So if matrix of Ij is equal to A, in that case, I'll increment the count. So I'll increment count 2 plus plus. Notice that. Okay, so that is what I'll do. Now, otherwise, if the position is odd, so if the position of the matrix is odd, then if it is odd, then if I have if it is odd and I'm following the second pattern, so if I'm following the second pattern and if the position is odd, then I need a here. So if I have a at the odd position, then I will not increment the count. But if I have a B there, then there is a conflict. If there is a B, then I need to change it. So if at odd position there is a B, then I'll count. So if the matrix of I j is going to be equal to B. So in that case, what I'll do is I'll do a count 2 plus plus, right? That's what I'm going to do. Now, after the counting has been done, so what we need to do is we need to return the minimum count. Okay, whichever pattern gives us the minimum number of swaps indirectly, we'll return that. Okay. Now let's try and compile to see if there's any error because the code is not long, but the explanation was a bit long. Okay, it says that J was not declared. So let's declare it as well. It works on the samples because for the sample you can see it is giving the output as 4 that we got in the dry run of this problem also in the very starting. Let's try and submit this problem as well. So you can clearly observe that my solution was able to pass all the test cases here. Okay. Now you will say that why you have taken two different loops. Can we do it in the same one loop? Yes, you can do it in the same one loop, but for the explanation part, I have done it. Okay. So this first loop I'm like this first n square loop I'm running to follow the pattern 1, and the second loop I'm running for the following the pattern 2. But if you want, you can do it in the same loop as well by using the else conditions. Okay. But this I have done for clarity purpose. Talking about the time complexity of the code. So time complexity will be nothing but order of n cross m only. And what is the space complexity? Did I take any extra space? No. So the space complexity will be nothing but order of 1 for my approach. If you are still here till the end and you were able to understand everything and you learned something new from this concept, so make sure to comment down understood in the chat, and also make sure to comment your feedback because it is very important for us. It will help us to improve. And don't go without liking the video because the problem was simple. I tried to explain it as simply as possible. It was a bit long because I wanted it to be in a bit of detail. So make sure to like the video and subscribe to the channel as well. Thank you for watching this video.